All right, so today we're going to talk about stormwater runoff, what it is, where it goes, and how to calculate it. So these are our topics. So starting off, where does stormwater go? Before we get into that, I want to define what stormwater is. So stormwater is all of the water that you incur or accumulate during any kind of rainstorm. So it could be a light drizzle up to a hurricane. So any kind of storm where there's water, that's what they're talking about with stormwater. And they're talking about the water that's being collected. So that water that's being collected, so when it rains, if it's a light rain, that water is going to all be absorbed by the ground, trees, bushes, plants, anything that we already have. Now, once we get so much rain, then you're going to have what's called runoff. So at this point, whenever you're going down the street and you're seeing water pooled along the side of the road or coming up in the ditches next to the road, maybe on in a neighborhood, the very sides, or in little puddles and stuff, that's your runoff. Okay, that's your stormwater runoff. A lot of times that's all going to go into your storm drains. It's going to go into a lot of our neighborhoods around here have lakes. Those are actually retention ponds where they have so much water currently, but they're made to hold water during a storm. There are things called detention ponds. We have some of those around the school where the ground is uneven. It's a little bit deeper than the rest of the ground, but it's always just kind of grassy. Those are detention ponds. Sometimes the water is going to be stored off-site. Sometimes it's stored underground. That would be your stormwater drains. And then all the water gets funneled out. So in our case, it gets funneled into creeks, streams, and bayous that go out to the Gulf and ultimately go into the ocean. All right. So when we add things to a site, so currently land has a set stormwater runoff, and there's so much water that it will collect and be absorbed by the ground, and then the rest of it will run off. Well, anytime we add buildings and we take away from the vegetation, we are actually increasing the amount of stormwater runoff, and we have to then we have to turn around and create the retention ponds, detention ponds. We have to increase our storm drainage systems. We have to make improvements. So there are different things that regulate stormwater management, things that are put in place to protect the environment so that the water quality is not going to harm anybody or any animals, creatures, plants, anything like that. There's things that are put in place to accumulate for erosion so that you don't want the ground under your house to erode away so much every time there's a storm that your house becomes uneven, your foundation will break. Okay, so there's all kinds of different systems put in place for stormwater runoff. So some things that we're going to be looking at that affect runoff is rainfall intensity. That would be talking about a light shower versus a severe thunderstorm. Okay, so how much rain is coming down and how much rain is coming down per hour. We're also going to look at soil type. So when you have a more rocky climate, that's not going to absorb as much as a pasture like a field. So different soil types absorb different amounts of water. Slope and topography. So the steeper the slope, the more chances you have of a mudslide. Then you have your soil conditions. How compact is your soil? And then how much vegetation do you have? So stormwater management, we're going to be calculating. And how we're going to calculate this is we're going to calculate based off of what we're given a pre-development runoff. So what is the normal runoff for that land? And then once that land is developed, we're going to calculate what would be a post-development storm runoff. And this calculation is actually determined before you do any kind of building. It's just saying, okay, if I build this house and it takes up this much square footage, or I add this parking lot with this much acreage, and so you're calculating and you're estimating how much runoff you're going to have once it's developed, then you're going to take those two numbers that you've created and you're going to find the difference. And the difference is what you're going to have to increase your stormwater management to include. So this is the formula that we use. Q equals CIA. Q is your peak runoff. Okay, your peak runoff is going to be in cubic feet per second. I is your rainfall intensity, which is your inches per hour. And A is your area in acres. So if your area is given to you in something other than acres, you're going to have to convert it into acres. And then C is the runoff coefficient. This is going to be dependent upon a surface, and we are actually going to use a table to determine this. Okay, so this is like your simple formula that you would use. We're actually going to use this formula. We're going to add the C sub F, which is our runoff coefficient adjustment factor, and there will be a table that you will use for that as well. So C sub F and C are going to come from tables. I you will be given in your, it will either be, you'll be given a table, or you will be given that in your actual problem. And then your area you will be given either in acres or in square feet. Don't forget, if it's in square feet, you need to convert it to acres. Okay. So the rationale formula using the C, okay, the recurrence adjustment, this table right here, this return period, so this is, the circle is off. It should be around C sub F. My PowerPoint got converted into a Google slide, so some stuff is off. All right, so C sub F, this table right here, and you will be provided with this table. So you literally are looking at C sub F, and then it's going to be one of these four values. It's going to be dependent upon the return period. Okay, your return period will be given to you in your problem. This is talking about years. Okay, so a return period of 1 year would be a storm that would naturally occur at least once a year. 50 years would be a storm that would naturally occur once every 50 years. Okay, same thing with 100, 25, 10, so this is all in years. So when we're talking about intensity, we're talking about the depth in which the water is coming down. So whether you're getting inches per hour or feet per hour, and then the length of the storm. So when you have a storm that only lasts an hour and you're getting 5 inches per hour, that's not bad. Now, if you were getting 5 inches per hour and the storm was going to last 8 hours, okay, then you're talking about 40 inches of water deep. That's not volume, that's just the depth. Okay, so that's on every surface. So you have to have a lot more, there's going to be a lot more stormwater runoff when we're talking about a longer storm. You could have a storm that lasts 1 hour and you get 5 inches, or you could have a storm that's going to last 3 hours and you get 1 inch per hour. And that wouldn't be, the 3 hour, 1 inch per hour wouldn't be as much stormwater runoff as 5 inches in 1 hour. And so that's kind of where you get into your intensity, is the depth and the duration. So both have to be taken into account. Okay, then we have, so here we're going to talk a little bit more about the return period. So you have a 100-year storm has a 1% chance of occurring in any given year. That's why we say it happens about once every 100 years. A 10-year storm has a 10% chance of occurring in any given year. There again, you have a 10% chance each year, so it's a 1 in 10-year storm. Typically happens every 10 years. The 100-year storm typically happens every 100 years. Okay, so usually your 100-year storms are a lot more intense than your 1-year storms, because your 1-year storms, 2, 5, all those, they're going to happen a lot more often.